In 9.5, we're going to divide square roots, and this is where where the numerator and the denominator aren't both perfect squares. So let's start out with square root of 15 over square root of 3. Remember that we can write square root of a over b is the same as square root of a over square root of b. We can go backwards and put these under the same radical sign if we want. So I'm going to do that, square root of 15 over 3. Now we can divide 15 by 3 and we get square root of 5. So my recommendation here is if you can divide these numbers, do it, because it's going to make things a lot easier for you. And you're going to see what happens later when you can't. But again, if you can divide the numerator by the denominator before you do anything else, do that. So let's say we have square root of 90 over square root of 2. We can divide 2 into 90, but just for kicks, I'm going to put them all under one radical. And so square root of 90 divided by 2 is square root of 45. And now we can't take the square root of 45, but 9 will go into 45, and it will go 5 times. So we can rewrite this as square root of 9 times 5, which is 3 square root of 5. So make sure that you check to see if you can take a square root of part of it. And again, if you can divide the numbers before you do anything else, do so. So let's say now that we have square root of 125 x to the 3 over square root of 5x. I'm going to write this as one radical. So square root of 125 x to the 3 over 5x. 125 divided by 5 is 25. X to the 3 divided by x is x squared. So the answer here is 5x. Okay, so what happens when we can't divide? And remember this, I'm going to bring this one up again to show you how easy the steps were here. And then I'm going to do it again using this next concept to show you why I'm saying if you can divide them, do so. Okay, so what we do when we can't divide them is what's called rationalizing the denominator. And to do that, we multiply both the top or the numerator and the bottom or the denominator by the bottom or the denominator. Okay, so what we're doing is we're multiplying it by 1, but for some reason we don't like to have square roots in the denominator. So if we have, say, 5 over square root of 3, what we're going to do is multiply the top and the bottom by square root of 3. So 5 times square root of 3 is 5 square root of 3. Square root of 3 times square root of 3 is 3. Remember when I said that concept of square root of x times square root of x just equals x is important to know? This is why, because what we're using that to rationalize the denominator. So let's say that we have square root of 7 over square root of 20. So the bottom here is square root of 20. So I'm going to multiply both sides, both top and bottom, by square root of 20. And when I do that, the bottom is just going to be 20. But notice that 20 is one of them that we've done before, which is 4 times 5. So before I multiply 7 times 20, I'm just going to break it up like that. So square root of 7 times square root of 4 times 5. So now I can take the square root of 4, which is 2, and square root of 7 times square root of 5 is square root of 35, and that's all over 20. But now I need to divide, simplify if I can. 2 will go into 20 10 times, so I'm left with square root of 5 over 10. Square root of 35 over 10. Now on this, you could have done that first. So let's say we have square root of 7 over square root of 20. Change this to be square root of 7 over square root of 4 times 5, which is square root of 7 over 2 square root of 5. And now we can just multiply both top and bottom by the square root of 5, because that's what we're trying to do, is just get rid of the radical in the denominator. So square root of 7 times square root of 5 is square root of 35. Square root of 5 times square root of 5 is 5. So I'm just going to put 2 times 5. And we're left with square root of 35 over 10. So you can do that if you want. Just remember, we don't want square roots in the denominator ever. Okay, so one more like this, and then I'm going to go back and show that other one. That was pretty easy when I did divide. So say I have square root of 2 over 45x. So now it's all under the same square root sign. And this time I am just going to keep the square, multiply it by square root of 45x instead of changing it to be 9 times 5. So I'm going to multiply this by square root of 45x over 45x. So they're in the same square root sign. We can go ahead and leave it like that. Now 2 times 45x is going to be 90x over, and that's, let me rewrite this so that it's neater. It's just going to be square root of 90x, but in the bottom we're just left with 45x because it was 45x times 45x under the square root. So now we have that. So now a 9 will go into the 90x. So I'm going to rewrite this as 9 times 10x over 45x. We can take the square root of 9, which is 3. We keep the 10x under the square root, and it's all over 45x. And we can divide 3 into 45 15 times. So we're left with square root of 10x over 15x. Okay, so on something like this, it's best to use the math quill to write something here where you have a square root over a number. You could put in parentheses square root of 10x, close the parentheses again, and then divided by 15x. Or, like I said, it's easier just to use the math quill where you can use the symbols. So let's go back to that one that we had. Square root of 125 x to the 3 over square root of 5x. Square root of 125 x to the 3 over square root of 5x. So if we did it like we did these ones here where we rationalized it, we'd multiply both sides by top and bottom by square root of 5x. When we do that, on the bottom, we're just going to get 5x. On the top, we're going to have 5 to square root of 725 x to the 4, 25, 10, 12, 5. Okay, so we have square root of 725 x to the 4 over 5x. And now we have to find a perfect square that goes into 725. Actually, that's 625. 625. Okay, we could, let me rewrite this so that we can read it. What we have here is square root of 625 x to the 4 over 5x. 5 times 125 is 625. So we could, if we knew that 625, the square root of that is 25, we could do that. And we would get 25 x to the 4 over 5x. And then divide and get 5x to the 3. But it would have been a lot easier had we just divided 125 by 5 and not had to worry about all this. If we didn't know that 625 was a perfect square, we would have said, okay, 25 is going to go into that, and then when we do the division, we'll find that it's 25. But again, if you can divide it at the beginning, do so. Don't try to rationalize when you don't have to. But if you have a square root in the denominator, you do have to rationalize it.